So let us see how to design a simple mini project in VHDL. Like I given a sine wave generator with NCO. NCO is nothing but numerically controlled oscillator. So when we want a digital system with a specific kind of pattern generation is required, we have a pattern in our hand in the form of integers. So we can utilize the NCO, that is numerically controlled oscillator concept, using a LUT in VHDL. So here I am going to generate a sine wave with the concept of NCO, and the main core element which I am using here is the mux. So the mux will be converted into lookup table. So I am showing you how to make this implementation. So we have a mux here. So this is the sine wave. I am just showing as a simple sine wave started from 0 to 0 crossing, and 1, 2, 3, the same thing will be repeated. So this is the numerical pattern I want to generate. So if I want to realize my FPGA as a sine wave generator, I have to load these values inside the memory of the FPGA using a LUT mux. So here I am going to design a simple 4-bit counter, so that 4-bit values will be continuously varied with respect to the clock, and those 4-bit will be given as a select input to the mux. So if there is a 4 select lines, means 2 power 4 combination output will be generated. That is 16 outputs will be generated. Here we have only 13 inputs approximately. So we have to adjust the sine wave according to it. So this is a sine wave I mentioned as a discrete samples. So I give 4-bit counter already, which we have developed the 3-bit counter. The same code I will take and make it as a 4-bit counter. Then I will automate the mux. Mux is a combinational circuit. I am connecting the combinational circuit with the sequential circuit. So now my mux has become sequential mux. And since we are loading the values, lookup table, looking up of certain pattern of values into the mux, now my mux acts as a lookup table. So let us see how to design this circuit effectively to have a simple mini project in VHDL. So our base circuit is counter, so we can directly take the counter coding here, so that will be easier for us with less number of typing. So VHDL is a robust programming language, but definitely have a large typing work. So I rename it as sine wave underscore gen. You can see my entity name and file name is always same. I don't know whether you are watching this accurately. So always I am following the rules. So clock clear, as per the diagram, clock clear and data will be the input, and that will be given as a selective mux, select line for the mux. So now I am making sine wave generation. So clock clear, data will be given, and output should be actually the sine wave. Now here we will take the integer as output. So no need of Q and all. So our goal is to generate a sine wave. So I name as wave out, that is output integer. Only in simulation we can see the integer values. So other than that, in hardware or real-time output, as I said in my first class itself, only standard logic and standard logic vector, that is the digital outputs, will be generated. Even in the mixed signal processes, the input as given as analog, output will be in digital. So I declare signal. So this I take it as select line. So I just name it as SEL. So 4-bit will be given to the select line SEL. So now we have to write 2 codes. First block is the counter block. So that is the 4-bit counter which is already there. So for this temp we have to declare and just give select SEL. Since we are generating only the select line, directly we can import the select line. So if you want to give any specific data, means obviously you need to mention the specific data over here. Otherwise default is 0, 0, 0. And now we have to create a secondary process called LUT. Process. What is my sensitive part of LUT is select line, and I have a clock, and I have a clear. So begin. So initially if clear equal to 1, then my mux should goes to 0, which means my wave out should be goes to 0. So wave underscore out the same equal to 0. Why I am giving 0 not with the quote is it is integer. Then here I have to write the sequential mux statement. So else if rising underscore edge of clock, then now write the case statement of mux. So to remember the mux concept, I will go to the mux code. So hope you remember the mux concept. Only the case statement you have to write. So I am typing the things completely for you. So when 4-bit 0000, 16 value should be there, but still we are repeating few things, so you no need to make 16-bit also sometimes, but here linearly only I am adding up. So my wave underscore out equal to, just follow the diagram. When it is 000, my first value will be connected to the mux output, which is nothing but the wave output will be 0. So to reduce the typing work, I just copy pasting it. Zero, 0, 1. Check the diagram. First value is 1. Then 2, 3. Likewise, we have to add 0, 0, 1, 0. Integer will be 2. 0, 0, 1, 1. It will be 3, which is the highest peak. I'm just copy pasting. I'm not doing it fast. 0, 0, 1, 1. Then 0, 1, 0, 0, 4. Making it as 2 again. And 1, 0, 1. 1. 1, 1, 0. 0 again. And 1, 1, 1. Making it to minus 1, correct? So as per this diagram, after this 0, it is minus 1, minus 2. So we are just creating a sine wave generator. So we only generating the pattern. So don't bother about how the sine wave looks. If you're looking for the exact sine wave, then you have to match the pattern accurately. So if you worry about the pattern, then you can go ahead with the values, that is the discrete values which you are getting. So just I'm typing it in only the linear format, nothing new. Minus 1. Again it should be continued. Hope you can understand. Again 0. So final value I just make it as when others condition. Others means default. So remember the mux code. When others condition is default. So when there is any others condition, just make it to 0. Hope that will be enough. And I have to end the case first. End case. And what and all I have opened? I opened if statement. So just end the if. And I need to end the process. So now my process is LUT. Unknown identifier temp. So yes, temp, I changed as select, no? Okay. Now everything is clear. Compile all, select. Sine wave generator. Go to the waveform. Add to wave signals and design. You can see the wave out is coming as integer. So it's showing the minimum and maximum value. So clock, as usual, right click and give clock. So clear, right click and force it to 1. Data, if you're having any specific data, mention it, otherwise 0, 0 will be the default. So now slowly you can run, make the clear to 0. So now you can see the values coming over as LUT, sequential LUT. Since we are not used the 16-bit completely, so you can see the values in between or default 0. So this is the final output, and I hope you wish to see the waveform in analog format. So if you want to see the waveform in analog format, double click, format, analog interpolated, make the maximum value to 4 and give it to apply, give OK. You want to see some colors, double click, go to colors, select any color which you like, apply, give OK. So if you give full run completely, here you can see the timer will be running. So right click and zoom full, complete sine wave generation will be generated. You can see how the numerically controlled oscillator will generate the sine wave kind of thing using a simple LUT operation. So this you can utilize as a simple mini project. And yes, you want to see the data flow diagram, right? So just click and drag it here. So you can see how we integrated. Everything will be clear in the architecture. So select line is connected to this as per the diagram. So select line is connected to the sequential mux. So this is LUT. Select line is connected and waveform output is coming over here. So lot of things are there in digital system design. So this course acts as a basic informative system on VHDL programming and followed by simulations using Menta graphics tool called MODELSIM. The same will be continued with other implementation tools like Xilinx ISE, LUTICE, Diamond and Actel based tools also. And the final code will be dumped inside the FPGA hardware, and we also have sessions related to this hardware dumping procedure, FPGA dumping procedure that will be follows. So keep on supporting us. So that course will be given to you in the next sessions. Thank you.